Good day everyone. This is Group 2 presenting our network discussion. Today we'll be talking about the network components and the network topologies. But before we move forward, let's look back into the first lesson. In the first lesson, we have talked about what is networking. So networking is the connection of two computers or many devices, and it is the backbone of our today's modern world. In today's digital world, networking allows us to access the internet, send emails, stream videos, and even operate smart devices. It is the backbone of modern communication and a key skill for any IT professional. For this part of the discussion, we will thoroughly examine the main components that make networks operate, such as routers, switches, NICs, and many more. We will explain what each component does, how it functions, and why it is important. After that, we will discuss network topologies, which refer to how network devices are arranged and connected. Topologies play a critical role because the structure of a network affects performance, reliability, cost, and maintenance. At the end of this presentation, we hope you will gain a deeper understanding of how networks are built and organized, how data travels inside networks, and how IT professionals design systems to meet the needs of schools, companies, and other organizations.
So good day everyone, I'm Justine Baltazar, and today we're gonna tackle or talk about the network components. So let us begin with the network components. So this is the building blocks that allow a network to function. Every network, whether it is a home, school, or business, it depends on the combination of hardware devices that work together to exchange data. Now let's proceed to the next network component we have. So we have the network interface card or the NIC. So it is a hardware component that allows a device to connect to a network. So you can think of it as the password of a computer because it gives the device the identity it needs to. Identity needs to communicate. Every NIC comes with a unique identifier called the MAC addresses. So which work like a fingerprint for the device. There are two main types of NIC. So wired NIC, which use the Ethernet cables, while we have the wireless NIC, which support Wi-Fi connectivity, which is a wireless. So without NIC, a device cannot participate in a network no matter how advanced the rest of the network is. So let's proceed to the next component we have. We have the switch or the switches. So a switch is a device responsible for connecting multiple computers within the same network, such as a computer laboratory. But what makes switches special is their ability to transmit data intelligently, unlike how switch broadcast data all devices. So the next component we have is the routers. A router is one of the most important devices in a modern network. So routers act like traffic managers by directing data between networks. For example, when you connect to your home Wi-Fi, your router sends your data to the internet and ensures information comes back to the right devices. So the next one we have is the hubs. A hub is a simpler device used to connect computers. But unlike switches, it sends data to every device connected to it, regardless of the intended target. So this often leads to data collisions and slow performance because of these limitations. Hubs are rarely used today, so they have been replaced by more efficient devices like the switches we talk about. And while hubs are important in learning the history of networking because they were among the earliest devices used in small local networks. Thank you. I'm calling the next reporter.
Thank you, Mr. Jensen. This is me now, KingTyron Maranan, continuing the next report. So we'll start with modems. A modem serves as the bridge between your network and your internet service provider. Its job is to convert digital signals from a computer into analog signals that can travel through telephone or cable lines. When data comes from the internet, the modem converts it back into digital form. Without a modem, your local network cannot access the internet. This makes the modem an essential part of home and business networks. Next will be the access points. An access point, also known as AP, provides wireless connectivity. as EPs extend a network's coverage by allowing devices to connect to the network without cables, wireless. Large places such as malls, restaurants, and schools rely on multiple access points to make sure Wi-Fi is available and strong everywhere. Access points makes networks more flexible and easier to expand because new devices can connect without needing physical wires. Next will be cables and wires, or cables and connectors. So these are wired networks, unlike the APs. Wired networks depend on cables and connectors to transmit data. The most common cables are Ethernet cables, just like the Cat5e and Cat6, which allow fast and stable data transmission. For long distances and extremely fast speeds, such as 5G Ethernets, fiber optic cables are used because they transmit data using light, making them resistant to interference. Connectors like RJ45 are used to plug Ethernet cables into devices. Although wireless networks are popular, wired connections remain essential due to their reliability and speed. And last but not the least, servers and clients. In a network, devices are often classified as servers or clients. A server is a powerful computer that stores data, manages resources, and provides services to clients. Clients are devices that request these services. So servers to clients. For example, when you log into your email, your laptop acts as a client, and while the email provider's server processes the request. So the email provider serves as the server. This setup allows networks to operate efficiently and organize data efficiently.
Now that we understand the key components that make up a network, let us discuss a network topologies. The structure or layout or how devices are connected, the topology plays a crucial role in how efficiently a network operates and how easily it can be expanded and how quickly issues can be diagnosed. The first one here is bus topology. In a bus topology, all devices are connected to a single central cable known as the backbone, and this structure makes it simple and inexpensive to install, which is why it's so popular in its early days of networking. However, our main problem with bus topology is the backbone cable fails, the entire network also fails. Additionally, as more devices are added, the network becomes slower due to data collisions. Today, bus topology is rarely used in large networks but can still be found in small or temporary setups. The second one is the star topology. Star topology is one of the most commonly used topologies today. In this structure, every device is connected. The central devices usually switch or hub. The biggest advantage here is that if the one device fails, it does not affect the entire network. This makes it reliable and easy to troubleshoot. However, the main disadvantages is that if the central device fails, the whole network will be affected. And star topology is widely used in schools, laboratories, and offices because of reliability and scalability.
Ring topology. Devices are connected in a circular arrangement. Data travels around the ring in one direction, passing through each device until it reaches its destination. This reduces collision and provides smooth data transmission. However, the weakness of this topology is that if one device fails, the entire network may stop working because the circle is broken. Now, the fourth one, which is mesh topology, provides the highest level of reliability because every device is connected to each other device. This makes data transmission extremely secure and efficient, since there are many possible paths for the data to take. Even if one connection fails, the network continues to operate using alternative routes. While mesh topology is reliable, it is also expensive and also complex to set up. It is mostly used in large organizations, data centers, and military systems where reliability is critical. And the last one, which is hybrid topology. that combines two or more topologies to create design that fits the need for a specific organization. For example, is a school might use star topology in classroom but uses mesh topology in its data center.
Let's talk about the disadvantage and advantages of all the topologies. First is bus topology. Advantages: very easy to set up because all devices connected in single cable. This makes installation simple even for beginner. Cost effective. Fewer cable and no need special equipment. Perfect for small or budget-friendly networks. Disadvantage: one cable failure equal whole network down because everything relies on the main cable. The single point of failure: slow performance with more devices. Too much data travels on the same line. This causes traffic and delays. Next is star topology. Advantages: easy to manage and troubleshoot. Every device is connected to a central hub. If one device fails, only that device is affected. Fast performance. Each device has its own cable to the hub. This reduces the data collision and speeds up things up. Disadvantages: hub failure can shut down the full network. Everything depends on it against a major single point of failure. More expensive, require more cable and central devices. Cost increase if your network grows. Next is ring topology. Advantages: smooth and orderly data flow. Data move in one direction. This avoid collision and keep information organized. Perform well under the heavy load because each device boosts the signals. It handles a large amount of traffic better than bus. Disadvantages: one device failure can break the entire ring. Connection is continuous. If link stops, everything stops. Harder to add or remove devices. Break in the flow of the ring, maintenance become a challenge. Next is mesh topology. Advantages: high reliability. And if every device connected for every other devices, there are multiple paths for data, reducing failure of risk. Strong security, direct and delegate connection, harder to unauthorized access to occur. Disadvantages: very expensive, require a lot of cables and connection, cost rise fast, complex setup and maintenance, too many links to configure, not ideal for beginner, and all small businesses or networks. Hybrid topology is the last. Advantage: high flexibility, mix of two or more topologies, great for growing network and needed to customization. Reliability and scalability. You can easily expand or modify parts without affecting the whole network. Perfect for colleges and companies and campuses. Disadvantage: can costly and mixing topologies means more device complexity. More design planning is required. Challenging to manage. Different topologies means different rules. Troubleshooting need more expertise. To help understand these topologies better, let's look at real-life examples we actually see around us. Number 1, bus topology. The real-life example of that topology is small network computer lab or the old setup. Next, star topology. Home Wi-Fi setups. For ring topology, we have the legacy office token ring. For mesh topology, we have the telecom and ISP backbone networks. Lastly, hybrid topology. University campus and networks is the best example of that topology.